Hello, everyone. In this lesson, we'll be writing integration tests. Let's start with a like test. So, let's go to our router IDS with this like idea and create a file which will essentially test the index.ts file. But not some separate function here, rather the entire method. That is, trpc will be run and will target this endpoint. This is not a unit test. It's a more complex check. Hence, it's an integration test. index.integration.test.ts. All right, and the content will be as follows. You might notice that I imported a lot from the test.integration folder, and we haven't created this file yet. This will contain all possible helpers for integration tests. What do you usually need in integration tests? It's the context of your application, where your Prisma is located. Because, firstly, you will need to create some data in this Prisma. And then, after your tests run, make requests to the database to ensure that the correct changes have occurred in the database. You often need to create some entities, particularly users, the ideas themselves, their authors, and so on. So, don't hesitate to write helpers. You write helpers, and then use them multiple times in various integration tests. And what's interesting here, you need to create some test version of trpc. There are two options. You can just set up the backend and send regular HTTP requests. But when you're working with trpc, that might not be the best solution, so it's better to make specifically a test version of trpc and interact with it. When we look at this trpc caller, it will become clear. But for now, let's look at the tests themselves. Again, we have a heading. Whatever it's called, that's what we'll make the heading. It will be clear. And we have two tests, creating a like and deleting a like. What are we doing here? Let's look at the function. The main idea. We created an idea and its author with one query. So, in number we pass, hold on a second. Number is just some sort of suffix, like user1, user2, and so on, to make it easier for us to check later. All right? We created the idea, and it ended up here. Created a liker. Well, a liker is just a user. So we had one author and a different liker. There you go. And then we create this trpc caller. That is, the thing that will call trpc. And we pass to it who will do it. Right now, when we make requests, there's an authorization header, but here our requests work differently. So we just need to create who calls this trpc. And this user will get into the trpc context. That's it. We created this caller. And now we can just call absolutely any of our endpoints. Specifically, we will call like with this idea and just pass input here. As a result, we get what is returned here from our return. Okay? Well, it returned in the result. And then we check that the result itself is adequate. Liked by me should return as true, and the number of likes should be 1. This means we've only confirmed that the endpoint itself returns the correct result. And then it's reasonable to check that everything is correct in the database as well. So we take Prisma from our app context, and we fetch all ideal likes, absolutely all of them, because tests are set up in a way that this we'll see in the helper later. We clean out our database before each test. Before each test, our database is empty, so we know there were no likes there. And after this, we can fetch all ideal likes, and their count should be 1. Again, the expect has the property to have length 1. And we also check that this is the only ideal like with too much object. So we can set some object here that should match the object right here. Even if we don't write everything into it, the main thing is that what is here should match. And the ID is the same as the originally created idea. And the user ID is that of our liker. This is what the create like test looks like. And the remove like test is very similar. We also create an idea with an author, create a liker, and then we like it. But again, we check that setting the like worked correctly. This is more convenient because it will be clear at which stage it broke if you were removing likes. That's it. and then you have result2, and you set idea like again, but pass false from like it by me. In result2, you should get like it by me as false, and the new number of likes should be back to 0. Go to the database, find all like IDs, and there should be 0. All right, these two tests. So, to call it, we do need to create our helper file. Let's create it and take a look. Okay, good. For this, we'll create a test folder in the src directory. And, inside it, a file named integration.ts. Integration.ts with the following content. Okay, good. We use create app context from libcontext, the same app context we create when starting our application. Great. App context is just created right here at the top level. After executing all tests, this function exists thanks to jest. After all tests, stop our context, whatever it may be. Here we have this stop function. Right now, we're disconnecting from Prisma. Before each test, we delete everything from ID likes, ID, and users. Now, this leads to all your created ideas appearing in the cooperation section of your database, but soon we'll ensure we have a different database for running tests. For now, we just clean everything so the database is initially empty in each test. Then comes the function getRPC caller itself. So what are we doing? Here we create a fake express context to insert the user. And right here we've seen yes passing this very user. Here, liker was just a user. We put it in request. And then the TRPC router, which is designed for TRPC, yes, this very TRPC router, has a method called createCaller. And you need to pass the TRPC context into it. And right now, with this function getRPC context, we don't have it. We have a function called getCreate to RPC context, which eventually returns this to RPC context through a couple of other functions. Therefore, we need to refactor something a bit here. We just need to split this function into two. So let's create a getTRPC context. In essence, this content ends up here. And here we will replace it with what we had. So this function will now return the following. So this is extra. Here's getTRPC context. We passed it here as we need the request. It's all the same here, but now we have separate access getTRPC context if you pass express request there, and if you pass app context there. Now we can use this in our helpers. Great. By creating this thing, we end up with a TRPC caller that we can then use like this. Just a TRPC caller, and then here we can pass the name of any of our endpoints and input for this endpoint, and simply get the result. It's very convenient to use. All right, this function. We'll go over this a bit later. And here are our helpers for creating some data. Create user. You can pass some additional fields to this user and a postfix that will be added to the nickname and email. Here, we take the password that we passed in user.password. If we don't pass anything there, the password will be 1234. Then we insert everything else we've passed into the user, except for the password, because we need the password to be hashed, yes. So, we can pass no data at all, then the default will be set. That is, nothing prevents us from specifying any username. Number is just an aid to create unique users. Then create ID. Well, everything is the same. Passed an idea, provided an author reference. The main thing is to have an ID, right? And you can pass this number as a note. Good. That's it, and here we just create our idea in Prisma. Here, we can overwrite absolutely any fields, as usual. This partial is a TypeScript directive that allows you to pass not all fields of this idea, but just some of them, that is, partially partial. Okay? And, well, we often need to create not just some idea, but we want to create it immediately with the author so that we don't have to pass the result from one function to another. It's easier to create something all-encompassing and use two functions under the hood. We passed something about the author, something about the idea that we want to replace. And that's it. We create a user and create an idea with this user. And we return the author and the idea. Well, and right now we're not using this helper yet. In our current test, we will use it in another. Well, you can also create a like for a specific idea. There's nothing complicated about them. Usual functions that create something in the database based on certain input parameters. Exactly. These functions will constantly change and evolve in practice. Just write the test, realize you're going to use a function a few times, and add it to the helper, and let this file be as long as needed. It will just make it easier for you to write the tests themselves. Good. So this is what our helpers look like. And now we can try to run our integration test. So, great. The test for creating a like passed. They work exactly the same as integration ones in terms of output. And you can call remove like. And remove like also passed. Great. These tests are working. Let's write some more. So, good. I'll mark this test. It might have been excessive in practice because we wrote these likes once, checked them, and they work. Well, a feature that in theory shouldn't break. That's right. But there's a feature that was really worth writing tests for, and tests for it should have been written even before we implemented this feature. Namely, it's a script that sends the most liked ideas to our user. We have an SQL query here, and last time we had to manually write it and test it with some sample data. At the same time, we didn't ensure that everything was working fine. Yes, we didn't have any ideas that were created more than a month ago. This is precisely the case where, to verify the functionality of this whole function, various data in the database is needed. It's easier to pre-create them with an integration test and, well, run the test, tweak the query, run the test, tweak the query. But unfortunately, we didn't have tests back then, so we had to do it this way. And in the future, if you're writing some SQL query, it's easier to first create an integration test and then try to write that query. And here, just output logs to the console from what you receive from the database. All right, let's write our test. Here. So we will have this. Renaming and creating new file integration.test.ts with the following content. So, here in this function, both the query is called and an email is sent. This is inconvenient for testing. So, since we are going to write a test, we need to separate this logic to check only that this query returns the correct results. Let's divide it up. So, okay, there will be a function, export const get most liked IDs. So, ktx limit. All right. And this is exactly what will be returned. Turn await. So. And now it needs to be called here. Turn await, get most liked IDs, ktx, and the limit was set to 10. Well, let's leave it as is. We didn't set any limit before. Let's keep it that way for now. So, literally, we just split our code into two, and they should return here and continue. Okay? Now we can start writing tests for our get most liked IDs. Great. We've imported this. We don't have date fins here, but we will need it because we will be changing our server time to ensure everything works correctly. Let's get to that point first and then install date fins. Where does it all start? As usual, with our header and then our test. I figured writing just one test would be enough here. There are two approaches, so you could write many tests and, for example, call it returns most liked IDs. In general, you describe precisely. For example, if the idea was liked this month, then the like should count there. Then write a second test. If the like was more than a month ago, it should not be considered. If a like was given to a blocked idea, it should not be considered, and so on. This is, in theory, a more correct approach, but often it will be more convenient for you to write some kind of comprehensive test. You simply create all the data at once and look at some total output to ensure it matches. This way, it might be more convenient for you to write this test in practice, but it's theoretically slightly less correct. At the same time, remember that tests are your friends, and you should feel comfortable with them. So if it's inconvenient to write a test, write it in a way that would be convenient if it's needed here. I'm just demonstrating that it's possible to do it this way, and there's nothing wrong with doing so. All right, here we're creating an idea and marking in advance how we'll give them likes, because this will be tricky to figure out, but here are comments right away. Has 3 likes from the previous month. This one has 2 likes from the previous month and 2 likes from the month before last. Has 1 like from the previous month, which we need now to mark the most liked, and 1 like 2 months ago. And this one has 3 likes, but they are all from the month before last, so in theory, they shouldn't be counted. And this idea doesn't have any likes at all. That means we predefined the ideas ourselves and got their authors and the ideas themselves. Then we do the following. We define our current time, and we consider that our current time is the beginning of the month, since we will actually call this function only at the beginning of the month. That's why we preset it this way. And the tests we can run today. And today is not the beginning of the month, but some other day. So, all right, we just defined the variable now and predefined 2 more dates that we will need later. This is some date in the previous month. That is, we take the current day minus 10 days, and we take some date 2 months ago. That means the previous current date minus 10 days and minus 1 month. So that's precisely, well, figuratively 2 months ago. And this date we'll already like. This date will not be included in our selection. All right? And then, according to the decision we made here, we create the corresponding likes. Here for the first idea, for the second, for the third, and for the fourth. We pass the one who liked so as not to create unnecessary users. Let these authors like each other's ideas. And also, when this ideal like was created, and pass the corresponding values here, there. One might want to say in tests, why didn't we create some helper here and write something like this here? Make likes in prev month 3, figuratively speaking. And here likes in prev month 2. Let this function immediately create likes and other things for us. Really, I strongly recommend not doing such things in tests. It's normal in tests to duplicate your values within one test, and it will be easier for you to work with this. Surely one day in your life, a situation will happen when you write yourself overly complex helpers. Then you leave, come back, and can't figure out what happened here. Here you need to find some balance, and I think this way is quite comfortable. Okay? And then there will be the test itself. So here is expect. And what do we expect here? We have the function without noise, but you can ignore it for now. Basically, it just removes unnecessary data from this object. But basically, it would be the same. We call this function get most liked ideas. I need to pass it the context. Well, because of the Prisma context. But I also want to pass a limit here. Why do I want to pass the limit? Because in practice, we have a limit of 10 here. And we need to check that if, for example, we have 3 ideas that have likes, they are sorted correctly, but the extra ones won't be included in the list. And instead of creating 10 random ideas here in this test, it's more convenient to just change this limit for tests. And for the actual application, keep the limit as it was. Therefore, we will pass the limit here now. Also, we need to pass now here. So it turns out that this function works as if today is not the actual day, but the day we need. That is, the first day of some month. So let's fix our function and make it as follows. Add input parameters, limit. And by default, this limit should be 10. Also, an optional now parameter to pass a date. Now, we also need to import the Prisma class from Prisma. Got it. And we'll create a variable SQL now. If now is passed, there will be Prisma SQL, where we convert now to a string date flagged as a timestamp. And if now is not passed, there will just be a simple SQL now, as it is now. And now we need to insert this SQL into the code. We insert it like this. Just as we insert variables into strings, we insert it here. This prisma.sql is needed to bring strings to a normal format and ensure that we don't have any SQL injections. It basically escapes everything unnecessary there. All right, so we have a limit now. We need to pass it as well. The limit is here. All right, limit passed. Like that, great. So, but as we remember, we have here. What do we see returned from this function? ID, username, name. Well, that's the main thing. And we have a situation where our database is cleared every time. And when we create ideas, their ID is some unique UUID string. So, and for testing, it will be inconvenient, or rather almost impossible, to know in advance what ID our idea has each time. So what are the options? When we preset ideas, here, we can specify in advance the ID we need. Or we can clear them. And for this, I created the function without noise. So this function will return some result. It's an array of objects, but there will also be IDs here that we don't need. That's why we write a helper without noise in our helpers for integration tests. And here we use the function deepmap. What's the idea here? Basically, we pass some input here. Ideally, it's an array of objects or something related. And we just go through the values. If the value is an object, which is not an array, because an array can also pass the object check. All right? And then we go through, this is scary. All right, it's purely some story about JavaScript and reduce. The main thing is if the keys in the object start and end with, in short, ID, or end just with ID in capital letters. For example, there's ID, then ID with ML cases, or for example, add. That is, created add, updated add. Because these entries also remain automatically with Postgres, and they are constantly different, and we don't want to consider them in tests. So, if it finds them, it skips them. And if it's not them, it returns them as they are. So that's what happened. We simply remove IDs and timestamps from there. That's all. Also a very useful function for tests. Okay, and next is the check. We call it on 2 ideas with the current timestamp, and we see that these ideas should hit here. The number of likes they receive we take based on this. And at the same time here, I also used too much inline snapshot, which was, these strings ended up here, the moment when the test was called. So we can do it again. So, only we need date.fns on the back end. We installed it on the front end, but we haven't installed it on the back end yet. Considering that we use it in tests, we could install date.fns in dev dependencies. But most likely, you'll need date.fns on the back end anyway, so we'll install it in regular dependencies. All right, let's wait for the installation, and let's run our tests to ensure they work fine. All right, the tests are installed. Running them. So it provided us 2 inline snapshots. It means it captured what was here in expect and replaced it here. And then it just checks that this is really what we need. Here we called a second time with a limit of 10 to see if it won't break if there are fewer ideas than needed, and only show those that exist. We had 5 ideas. This one had no likes, so it didn't make it. This idea had 3 likes, but all were 2 months ago, so it's also not included. We just need to check that these ideas got in and have the necessary number of likes. And we see that the first idea should have 3 likes, the second should have 2 likes, and the third idea 1. Let's check. The first has 3, 2, 1. Excellent. And here 3, 2. That's it. The function works. And this was indicated by the integration test. In practice, it's more convenient to work with when developing through tests, to call them via the console. You do it like this: rename, copy. Or again, the path of this test, pnpmb test. If you have many tests, use only here. Insert the path and start writing your code. For instance, you initially had, you just started, and I don't know, you wanted to at least check if this structure basically works. Yes, you could have done it like this, and you would like to see what you actually get back as a result of this function. At this stage, you would only set the ideas. There's no conversation yet about checking if it works correctly with the idea of likes. You wouldn't have this code yet, and here you would write console.log. Oh well, that's how you would do it. Git most id likes. During development, you could name this variable whatever you like. It wouldn't matter to you. That's it. And you did console.logx. That's it. Code saved. Run the test. Don't look at the test anymore. Just focus on your task. Called it. You know that all necessary variables have been created in your database now. Aha. See, you wrote something wrong. Like, oh, need to fix that. You made an incorrect order by here. Saved it. Press the up arrow on the keyboard again, and your last command was called. Start it. Okay. Broke something there again. Your code still isn't working. Then launched it again. Okay, checked it. The fact that the test worked isn't important at this stage. What's important is that your console.log outputs. Aha, it outputs this. Great, you understand. Okay, I can continue working with this. And there you write something again. And so you slowly change, and you already get some final state. So in the end, you got to this point. Call it again. Look. Yes, a great result. Good. The only thing you understand, yes, those IDs are unnecessary. So, go and write yourself a helper to remove these IDs. Nothing would stop you, in principle, yes. And here you can simply filter it through map, yes, in this result. But you'll have to do this constantly, in different tests. Therefore, a helper in this situation will be more convenient. And that's it. Once you're sure everything seems to be working fine, write out the part of the test that checks the incoming data. Before this, you just called console.log. That's it. Finally, you run your test and make sure it works. That's it. Great. We wrote 2 integration tests, and now I want to show you the following. If you now run the pnpm btest command, you have 2 integration tests here. And there are some unit tests as well. When you run this, all these tests are executed in parallel. And you see what happened? We have 1 test failed. We're told there's some database error, and that idea ID didn't work. What could this be related to? Here in this test, we created an author and idea that had the same username and identical fields. And in this test, we created something similar. Since these tests ran in parallel, they conflicted. To prevent this, I suggest running back-end tests one after another. And for this, you can add a flag like run and bend to the test command in your JSON package. Then all files will be executed sequentially. Call pnpm test once more. That's it. All tests passed sequentially. You can also make unit tests run in parallel, while integration tests run one after another. In practice, unit tests run very fast. Running them in parallel doesn't change anything, but integration tests still need to be sequential. In principle, this will be enough, but there is room for improvement. Okay, thank you all. We wrote integration tests and can move forward. See you soon.